Alright, how's it going, guys? This is our vector test review, so I'm going to kind of go through it as quickly as I can because I know you guys want time to watch it. So, number one, find the angle between the following vectors A and B, giving your answer to the nearest degree. Okay, so here are the vectors A and the vectors B, is what we have here. So, to find an angle between two vectors, we're going to use the vector dot product. There's a formula for that. It's the dot product of A, vector A, and vector B, so dot product of A and B. It's equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. So I'm going to change my color here. And what I need to find are three things: the dot product, the magnitude of A, and the magnitude of B. So I'll find the dot product here. So the vector dot product of A and B is simply found by taking the x component, which is your I coefficient, of A and B, so negative 4 and 1, and I'll multiply them. And then I'll add the j coefficients, which are your y components, which is negative 2 and negative 7. So what I have here is negative 4 plus 14, which is in fact 10. Okay, that's 10. So that is the vector dot product. It's a positive number, which is 10, and that tells you it's an acute angle. So now we need to find the magnitudes. So let's change my color up to green. So the magnitude of A is found by taking the square root of A's components, which is negative 4 and negative 2. Square them both, add them together underneath the square root. So negative 4 squared is 16. Negative 2 squared is 4. So this becomes root 20. That's the magnitude of A. We have to find the magnitude of B as well. So that's going to be the square root of 1 and negative 7. So 1 squared plus negative 7 squared. Negative 7 squared is 49. 1 squared is 1. 49 plus 1 is root 50. So now we have this. We have this, this, and this. We have three of them. And we need to figure out this cosine theta. So, very well. So what I'm going to say then is I'm actually going to go back to this equation here, and I'm going to divide both sides by the magnitude of A and the magnitude of B. Both sides, okay? Everything you do on one side, you do the other. And we're going to cross these out. So that means that cosine theta is equal to this, all right? Now, that's great for cosine theta, but I don't want cosine theta. I want the angle. I just want theta itself. So I need to get rid of the cosine. So what I'll do is I'll take the cosine inverse of both sides. And what happens is the cosine inverse will cancel out the cosine. So theta is equal to the cosine inverse of this. So basically, theta is equal to the cosine inverse of the dot product of A and B, which is 10, we just found, divided by the magnitude of A times the magnitude of B. The magnitude of A is root 20, and the magnitude of B is root 50. So, if you type that into your calculator, making sure that you're in degree mode, because my computer here doesn't have the software I need to show you this, so I'm just going to do it on my calculator here. You'll have a calculator in class, of course. So, let's check this. So cosine inverse, small TI Inspire. So control divide, and 10 divided by root 20 times root 50. Very quickly. All right. That would be useful. And that's going to be about 72 degrees if you round it to the nearest degree. So that's going to equal 72 degrees. All right, so that's pretty much that. Let's go on to the next question, which is 3. All right, so number 2. Alrighty. So number 2, 3 coordinates of a parallelogram, STUV, are S, T, and U. Find the vector ST and hence the coordinates V. So the vector ST is basically a vector leaving T and going, well, leaving S and going to T. So what I'm usually going to do is I'm going to take the ending point, which is where it's going to terminate at T, and I'll subtract where it began, which is S. Okay, so it's going to end at t, which is 7 and 7, represented in vector components. And I'll subtract where it began, which is -2 and -2. So 7 minus -2 is 9. And this one is also the same. It's 9. So this is the vector st. Found it. Now this hint stuff means find the coordinates of v. Now this requires a little bit of intuition here. All right. If I were to sketch a graph of what's happening here, let's put some points down. S is -2, -2. So I go back here and down here. It's like right here. That's where S is. -2, -2. All right. T is 7 and 7. So I want to go over 7 and up 7. So it's going to be like right here. That's where T is. U is 5 and 15. So I go over 5 and up 15, which is way up here actually. Okay. This is going to be like U, kind of where that is. And I'm looking for a parallelogram called STUV. All right. So this is pretty straightforward. Parallelogram says go from S to T, from T to U, and then from U to V. But V is going to have to be somewhere over here, because if it's a parallelogram, it's going to have to look something like this. So somewhere over here is V, this point. And I don't know exactly where it is, but somewhere over there, okay? So what we're going to use is some more intuition to figure this out. ST is this vector right here. S to T. I just found this, okay? And what this is really telling me is that 9 and 9, I'm going 9 this way. In the x direction, I'm going 9 up. That's what this means, to go from S to T. I'm going 9 this way and 9 up. All right? So technically, I'm doing the same thing here. I'm going 9 this way and 9 up. This is 9 and 9. So if they tell me this coordinate right here is 5, 15, then if I go backwards, I'm at 5. If I go backwards 9, I'm going to be at -4. And if I have 15 and I go down 9, it's going to be 6. So this right here is the coordinate for v. It's -4, 6. That's what they wanted me to find. So I'm going to say, okay, v is actually -4 and 6, by the way. Okay, so that's your answer for this, and here's your vector st. So those are your two things they wanted you to find, the vector and the coordinates. No problem. Okay, find the vector equation of the line uv in the form r equals p plus lambda d. All right, where lambda is a real number. That's what that means. Okay, so this is very typical for a vector equation of a line. There are two things that I'm finding. One of them is a point on the line, which is p, and the other one is direction, which is d. Okay, well, the vector is going to go in the direction from u to v. So look, we have this. Let's actually get a different color. I need a different color, right? So let's get, this green's fine. Okay, so from u to v in this direction, I got a vector, okay? And there's a line here. That's what I'm telling you. There's a line going this way forever. But this is telling me the direction of the line from u to v. So what I really need to do is figure out what uv is, okay? All right, so I'm going to say that's the same thing as v, where it ends, minus u, where it begins. And that's going to be -4, 6. We just found the coordinate for v, which is -4, 6, right here. And we're going to subtract the coordinate for u, which is 5 and 15. This is going to give me -9 and -9. It is worth noting that this right here is the exact opposite vector of this one. This one is going this way, st, and this one is going the opposite direction, and they're parallel. So to make a vector go in the opposite direction as the one you already have, you just make the signs the opposite. So these are both positive, so these will be negative. That's really all there is to it. So this is the direction the vector or the line is going from u to v. It's the direction part. It's this thing right here. It's the d. It's actually what? I'm telling you it's -9, -9. All I need for this is a point. And we have two. We have v and we have u. We could use either one. So I'm going to use this point here that I already have, which is on the line, which is v. So let's write the vector equation in this form. Okay. And it's going to say, I usually write it as xy. That's what I usually do. And I'm going to say that's equal to the point. And the point is what? negative 4 and 6, some point on the line. In this case, I'm going to use v. And it's going to be plus a scalar called lambda, that's what they're calling it. And it's going to be multiplied by the direction, which I'm telling you is negative 9, negative 9. So this describes the direction of the line, and this is just the what? This is just the point, which is negative 4 and 6 I chose, okay? So that's that. That's actually the vector equation of the line, and it's described accurately. All right. Number 1, part C here. Is this number 1? It's number 2, sorry. Number 2, part C. Show that the point E with position vector 1, 11 is on the line UV, and hence find the value lambda for this point. To show that this is on the line, that means that I'm going to have to take this point, add this scalar times this point, and I should be able to get the point that I want, the target point, and the target point is point E. They want this to go into xy. So I say, okay, so xy is 1 and 11, supposedly. And the only way that this right side will equal the left side is if there's some scalar called lambda that I can plug in here that'll make it happen. So, and that's what they want me to find. They want me to find lambda for that point. So I'm going to say, okay, so negative 4, 6 is a point on the line. Oops, let's undo that. So negative 4, 6. And this is going to be added to lambda times negative 9 and negative 9. So we're going to make two equations out of this very quickly. First equation is 1 equals negative 4. Let's write that. 1 equals negative 4 plus negative 9 times lambda. So minus 9 lambda. That's one equation. The other equation is 11 equals 6. I'm going to write it over here. 11 equals 6. Okay, plus negative 9 times lambda. So minus 9 lambda again. So we'll solve these equations for lambda. If, in fact, there is a single value of lambda that will make the left side equal the right side, I can then show that point E is on the line. So I have to get the same lambda for both equations. So let's try. Let's add 4 to both sides. That's 0, and this is 5. So if 5 is equal to negative 9 lambda now, that means lambda is equal to negative 5 over 9. It's one of my lambdas. The other one I'm going to solve by subtracting 6. So that's 5, and this is 0. And this is equal to negative 9 lambda again. This right here is the same thing that I already had. So again, the answer is going to be negative 5 over 9. So as it turns out, lambda for this point is negative 5 over 9, and because of the same for both equations, I have shown that point E is in fact on this line UV. That's how it's done. All right. Keep moving on. The point W has a position vector a and 17. A is a real number. If the magnitude of EW from point E to point W is 2 root 13, show that one value of A is negative 3, and then find the other possible value of A. Okay, that's pretty straightforward, but the first thing I need to find is the vector EW. So let's define that. EW, a vector from E to W, is W where it ends minus where it begins, which is point E. Okay, W, they tell me, the only thing I know about point W is that it's A and 17. So A and 17. I will subtract point E, and E, they told me up here, point E is actually 1 and 11. So, following this, it's A minus 11, which is A minus 1, so it's A minus 1, and then 17 minus 11. 17 minus 11 is 6. So this is the vector EW. And so the next thing they're talking about is the magnitude. So I need to figure that out. They actually tell me that the magnitude is 2 root 13. So let's find the magnitude in formula form. We take this by, find this by taking the square root of this part, A minus 1, all squared, plus the other component, which is 6 squared. So what this really is A minus 1 all squared, which is A squared minus 2A plus 1. It's like saying A minus 1 times what? Times A minus 1. If you multiply these out, you'll get this. That's what I'm telling you. I'm going to add 6 squared, which is what? 36. So in the end, it's going to equal A squared minus 2A plus 37. And that's going to equal something. It's going to equal actually this, 2 root 13. But we need to actually kind of simplify that a bit, make it more useful. If I look at this, and this is equal to this now, it's the same magnitude, okay? This is the magnitude of EW, this is the magnitude of EW, so this is equal to this. 2 root 13 is actually the same thing as root 4 times root 13, because the square root of 4 is 2. So really what I'm saying is this is the square root of 4 times 13, which is actually the square root of 52. So this being 2 root 13 is actually the same thing as the square root of 52. Now it stands to reason, if you're a logical person, that whatever's inside this radical is the same thing that's inside this radical, because they're equal to each other. So now I can say that a squared minus 2a plus 37 is in fact equal to 52. If I subtract 52 from both sides of the equation, I'll say a squared minus 2a minus 15 is actually equal to 0 now. Now I'll factor. Factors of negative 15, two numbers that multiply to negative 15 but also add to negative 2, are a minus 5, so negative 5, and positive 3. So negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. Set both these factors equal to 0, and then your answers are 5 and negative 3. Now, I look at this answer here. I look at the answer here, and I already know a is negative 3. That's one of the answers. The other possible answer is a is equal to 5. So that was the other possible answer. Okay? So we're going on to the next question. Let's go ahead and change my pen color. For a is negative 3, calculate the angle between EW and ET. All right. Well, again, I have to find EW and ET. So EW, let's take a look at this really quick. EW is, it's this, we have it up here. It's a minus 1. But a is negative 3. So what is negative 3 minus 1? It's negative 4. The other number is 6. That's the y component. ET we have to find as well. And that's going to be the point T minus the point E, where it ends minus where it starts. Now, if you recall, because probably you don't at this point, but T was given to us. At the very top of the problem, T was 7 and 7. So that's where we're going to start. T, 7 and 7. We're going to subtract E. And E, if you recall, they told us up here, actually, point E is actually what? 1 and 11. So we have to keep recycling these old answers. 1 and 11, these old parts of the question. So 7 minus 1 is 6, and 7 minus 11 is negative 4. Okay, almost done. So it wants me to find the angle between two vectors. This is always done the same way. In this class, we take a vector dot product. So what I want is a vector dot product between EW and ET. So we're going to take the magnitude of EW times the magnitude of ET. And this is going to be multiplied times the cosine of the angle between them. So the dot product of EW and ET is found by this part right here. This is found by multiplying the x times the x. So this is going to be negative 4 times 6 plus 6 times negative 4. And what I'm noticing here is that this is negative 24 minus 24. So this is actually negative 48. This is equal to the magnitude of EW. Now, let's change my color really quick. EW, the magnitude of that, is the square root of EW's components, which are negative 4 and 6, all squared. So this is actually 16 plus 36, which is the same thing as the square root of 50. Same thing as the square root of 52. So this is equal to the square root of 52. That's what this is right here. ET, though, has the same numbers, 6 and 4. Same thing as 4 and 6, really. And when they're squared, they become positive anyway, so it doesn't make any difference. So what I'm going to do is say, well, the answer is the same. Okay? If I squared this and this, and I squared this and this, I'll have the same number. So basically, EW and ET are both the same. They're both root 52. And I'm going to multiply. times cosine of theta. So root 52 times itself is actually just 52. And this is equal to this. So let's just divide both sides by 52. And now theta is equal to the cosine inverse of negative 48 over 52. So let's put that in the calculator. We'll have our angle, and then we'll be done with this question. So cosine inverse of negative 48 over 52. This is 157, about 157 degrees, somewhere thereabouts. So that's the answer for that one. Okay, so number 3. Let's see if I actually can switch my screen up here. Let's do dual display. Try that. Yeah, it's kind of not good. Yeah, that's what I was afraid of. Keeps adding things after. What I want to do is insert a page here. Okay, so let's actually view the dual display again. All right, that's what I want. So let's do this. Let's do that full screen. All right, so I'm gonna try to work like this. All right, so the diagram shows points A, B, and C, or the 3 vertices of the parallelogram A, B, C, D, and point A is 2, 2. So if I go from the origin 2 this way and 2 up, that's where point A is, pretty much what it means. Write down the position vectors of B and C. Okay, that's pretty easy. Just look at the picture and follow from the origin. So from the origin to get to B, I'm going to go back 1 from here to here, and I'm going to go up, looks like 7. So B is going to be negative 1 and 7. That's pretty straightforward. C, from here, I'm going to go over this way, 5, 6, 7, 8. That's where that is, 8. So the x component is 8, and the y component, it looks like if I trace it, it's going to be about 9-ish, right about there. So 9. So the position vectors for B and C are negative 1 and 7, and 8 and 9. The position vector of point D is D4. Find D. Well, that is a little tricky, but not that hard. This is a y value. D, this coordinate, well, the point D has 4 as its y value. So if I imagine y equals 4, it's a horizontal line. It's right here. This is where y is 4. So everywhere on the graph that y is 4 is on this horizontal line, if I kind of sketch one. And I know that the point that I want is on that line somewhere. I don't know where the x value is, but I know that the y value will be a 4, so it has to be on this line. Now, as it turns out, it's a parallelogram. It goes from A to B to C, and then to D. So it goes from A to B, and then from B to C, and then D's got to be around here somewhere. I don't know, but it's going to be about right there, so that I can complete what is basically looking like a parallelogram. So I have A, B, C, A, B, C, and D. Okay, so if this is true, and I have this picture going on here, just to kind of tell me what's happening. To find D, I'm going to create a vector. Okay, what I want is a vector from B to C. That's really what I want, from B to C, because that'll be the same vector as from A to D. They'll be identical. Okay, so to get a vector from B to C, I'm going to take C and subtract B, the end minus the beginning. We know that C is this, and we know that B is this. So it's going to be 8, 9 minus negative 1 and 7. What this will give me is the vector 9 and 2. So what this means, in case you're not sure what's happening, is from here I'm going to go over 9 and then up 2 to get from A to D. This is what I've done to B to C, because I just found this. I'm going to go over 9 and up what? 2. So I did that. I went up over 9 and up 2 to get from B to C, and that's what I found. That's why it's telling me the components are 9 and 2. So these will be the same. But since point A is the same thing as 2, 2, then from point 2, 2, I need to go over to the right 9 and up 2. So what is 2 plus 9? Well, that's 11. And then if I go up 2, from 2, 2 plus 2 will be what? 4. So this is actually the coordinate for D, and they're asking you for D, and D is what? It's going to be 11, so that's your answer. Okay, that's what that is. And then 4 is already there. Find BD. Okay, that's pretty simple. BD is what? It's D minus B. The great thing is we found D. The coordinate D is 11 and 4. We just found it. If you got this question wrong, you're probably going to get this one wrong. That's how it always works. So you have 11 and 4 minus B, which is what? Negative 1 and 7. So 11 minus negative 1 is actually 12, and 4 minus 7 is negative 3. So that's the vector BD right here. It's 12 and negative 3. That's pretty much it. Okay. A line passes through B, the points B and D. Okay. Oh, that's great. So if I'm imagining a graph, a line from point B to point D, if we have a line doing this, going from here to here, it's kind of what it's doing. Okay. What I want, let's get a different color. I need something I don't know if you can see this too well, but what I need, of course, is a direction vector, and that's the direction from, yeah, you can't see that at all. I need to get something you can see. I'll go with purple. I need a direction from B to D. That's what I need. Okay, so that's my direction vector. When you write a vector equation of a line, you see what they're giving you here. It's really going to equal a point plus some scalar, which is they usually call t, times direction. If I have a line that has B to D, B and D on it, I can make a direction from B to D. So that would be my D vector. It's the direction, which will be the same thing as B to D, which is 12, negative 3. That's going to go here. This is just a point on the graph, and I know that B is a point on the graph, and that B is negative 1 and 7. That's why they have chosen my point here to be what? Negative 1 and 7. It's just a point on the graph. So to write this vector equation of a line is pretty simple. We just say xy, which is what we have here, equals the point B, which they're giving me is negative 1 and 7, plus t, and I told you this direction is what? From B to D, which is 12 and negative 3. So this is actually the vector equation of the line. That's it, right here. Now they want me to find, this is D part 2 we're doing. Now they want me to find the value of t at point B. So if I tell you this was the vector equation of my line here, let's just copy it real quick. Okay, they want me to find it at point B. Now I want you to consider point B. Point B, I told you, was negative 1 and 7. So this x and y, we're going to make them negative 1 and 7. And this is going to equal negative 1 and 7 plus t times 12 and negative 3. The question is, what's the value of t have to be for this left side to equal the right side? Well, that's pretty easy. These are the same, which means I don't want this to be here at all. So how do I get rid of this? I have to make this t value equal 0. Because 0 times this will make this go away, which means these will be equal. So the value of t at point B is, in fact, 0. That's the correct answer. All right, so let's keep going through this. Keep going. Let point be the point 7, 5. That's what it says. All right. By finding the value of t at P, show that P lies on the line L. So they want me to find the value of t there. Interesting question. So this is E. We're going to take the same exact equation of the line. Let's copy it again, just to show you that I'm using the same thing over and over again to answer all these mundane questions. Okay, so they're telling me point P is on the line, so it's 7 and 5. That means x and y is point P. It's going to be 7 and 5. And I'm going to set it equal to the rest of the equation. If I can find a singular value of t that I can multiply by these two numbers, add these two numbers to them, and get these numbers, then I can prove that this is actually a point on this line. So let's create two equations. 7 equals -1 plus 12 times t. Look at the top. So 7 equals -1 plus 12t. The other equation is 5 equals 7 plus -3 times t. So 5 equals 7 minus 3t. We're going to solve both equations for t, and if this is true, if this point is on the line, t will be the same for both equations. It's a singular value. So let's add 1 and add 1. This is 0. This is 8. 8 is now equal to 12t. That means t is equal to 8 over 12, which is equal to 4 over 6, which is the same thing as 2/3. So that's the answer I got for t. This one I'll solve by subtracting 7 from both sides. So 5 minus 7 is -2. So -2 equals -3t. Let's divide both sides by -3. A negative divided by negative is a positive, so again t is going to equal 2/3. So because these values are the same for t, I have shown that point P is actually on this line. So it says find the value of t, and of course t is going to be 2/3. 2/3. All right. Show that CP, last question here, is perpendicular to BD. Now, a vector, two vectors that are perpendicular form a right angle, which is 90 degrees. That means that the dot product of CP and BD, if they are perpendicular, should equal 0. It would mean that these are orthogonal. So what I need to first figure out is define CP and define BD. So we'll find those first, and then we'll try to prove that they are in fact orthogonal. So CP is P minus C. And P we just found is 7, 5. They tell me that in this question. So it's 7 and 5. And C, if I go back up here, it says it's 8 and 9. I already know that. So 8 and 9. So 7 minus 8 is -1, and 5 minus 9 is -4. That's what CP is. Let's find BD, the other one. BD we already know, we found it. It's actually right here. It's 12 and -3. We're recycling answers. So now let's find the dot product of these two vectors. All right. So the dot product of CP and BD is in fact equal to the x times the x, which is -1 times 12, plus the y times the y, which is -4 times -3. -1 times 12 is -12, and -4 times -3 is 12. If I add -12 to 12, I will get 0. So I've proven this dot product is equal to 0. Thus, CP and BD, these two vectors, are orthogonal, also called perpendicular. Same thing. Okay. Just because the dot product is equal to 0. That's proof of that. So, that's that. We've done that question. Let's keep turning the page, and we'll go on to the next page. All right? Because I very much would like to finish this at a reasonable hour for you. So, let's get started right away. All right, so number 4. Points A, B, and C have these position vectors. So right here, A, B, and C. A, B, C. They give you all of them. Let D be a point on the x-axis such that ABCD forms a parallelogram. Find the vector BC. That's really easy. The vector BC is where it ends, which is the point C, minus where it begins, which is the point B. So C, they're telling me, is this right here, which is the vector components -5 and -5. And we'll subtract the vector components for B, which is right here, which is 1 and -3. So 5 minus 1 is -6, and -5 minus -3 is -2. So this is the answer for part A, part 1. Now it wants me to find the position of vector D. This again is a little more challenging for those of you who have trouble visualizing two-dimensional shapes. Let's actually undo that. But don't fret, it's really not that hard. I'm going to erase it really quick. Use a small one. Okay. So let's try to draw a graph here. Not so good, but we'll try. All right, so point A. Point A is 4 and 2. So I go over 4 and up 2. Point A is about right there. Okay, just guesstimate it. B is 1 and negative 3. So I'm going to go over 1 from here and go down 3. So B is kind of like there, give or take, right? And then C is negative 5, negative 5. So from the origin, I go back 5 and down 5. So it's like right here. Okay? And this makes a parallelogram. There's a third point called D. And all I know about the point D, they only tell me one thing, is that point D is on the what? The x-axis. So it's somewhere over here on the x-axis. Something like this, if I had to guess. And this is really not drawn to scale, but if I go from A to B to C to D to this, it's supposed to form some sort of parallelogram. Does that make sense? So it looks kind of like that. Again, this is not a great drawing, but you really don't need to draw is what I'm trying to get this point across here. So what's the position vector? Well, it'd be nice to know this vector here from C to B or from B to C, because I can figure out how far down to go and how far to the left to go if I knew this vector, these components. And that's what I found. I found BC. That's why they made me do that. Okay, so this tells me to go over 6 and down 2, down 2. I'll do the same thing here. I'm going to go down 2 and over what? And over negative 6. So point A, which I already know, is 4, 2. I know this coordinate is 4 and 2. They tell me that. So 4 minus 6 on the x here is going to give me 4 minus 6 is negative 2. And 2 minus 2 on the y is going to give me 0. So this is the coordinate for point D. It is actually negative 2, 0. And that's the answer. Okay? So that's the position vector for D. Now they want me to find the angle between BD and AC. So imagine this. BD is actually a diagonal of this parallelogram. And AC is also another diagonal of this parallelogram. And what's important to notice is that I start here and then I go all the way to the arrow here. But I don't have to start it here. I can start it here and just go this way. It'll lengthen, it'll make it look, the vector look longer, but it's just only because I'm moving it along the line here. If I take this point and put it there, I can make this vector the same as this one. So basically these are the same vectors. I just kind of moved them over a little bit. And what this is telling me is this angle here in between where the vectors start, this one and this one, is this. That's the theta that I'm trying to find. That's the angle they're interested in. It's not any other angle besides this one. And it's important that you understand that, okay? If I wanted this angle, I would have to have a vector pointing this way, and I don't. I only have a vector here and a vector here. So, to find that angle, all this talk, we just use a vector dot product. We'll take the dot product of BD and AC. This will equal the magnitude of BD times the magnitude of AC times the cosine of the angle between them. So, let's find them. I really don't know what BD is. I haven't found it. It's not anywhere. It's not given to me. So I actually have to define BD. So the vector BD is the end minus the beginning. It's D minus B. D I now know is negative 2, 0. And vector B right here, they told me, this one right here is 1, negative 3. So negative 2 minus 1 is negative 3, and 0 minus negative 3 is positive 3. So this is the vector BD. Let's find the vector AC. So that's C minus A. C I now know, or already know, is negative 5, negative 5. And I'll subtract the vector A. And the vector A again is 4 and 2, to reiterate. Okay. So negative 5 minus 4 is negative 9. And negative 5 minus 2 is negative 7. So this is my vector AC. Now we must find the dot product between them. And we're going to try to solve this equation. So I'm going to find the dot product of these two vectors. So the dot product of BD and AC is found by taking the x times the x on these. So negative 3 times negative 9. And adding the product of the y times the y, which is 3 times negative 7, excuse me. Sometimes I get a little quick when I'm writing this math problem. So it's going to be negative 7. So this is negative 3 times negative 9, which is 27, minus 21. So this is going to be 6. That's a dot product. So I found this part. This part right here, I'm telling you, is 6. That's what this is. And let's find the magnitudes of BD and AC. Sorry. So BD, the magnitude, is equal to the square root of BD's components, which are negative 3 and 3. So negative 3 squared plus 3 squared, which is 9 plus 9, which is root 18. So this is root 18. And let's find the magnitude of AC. Take the square root of its components, which is negative 9 and negative 7. So negative 9 squared plus negative 7 squared. So that's actually 81 plus 49, which is 130, is really what that is. So that's the square root of 130. So the only thing we need to figure out is cosine theta. So let's rearrange that equation. Let's rearrange this equation. I'll tell you theta is actually equal to 6. Well, it's actually equal to, that's not true. It's actually equal to cosine inverse, okay? Let's actually write that first. At least we forget. Let's actually select the eraser. Probably a good idea. It's actually equal to 6. So cosine inverse of 6 divided by this times this, okay? Which is root 18 times root 130. So I'll tell you this on the calculator, whatever that is. That's the angle I'm looking for. This is a long problem, by the way. And we're almost done, though. So cosine inverse, this is going to be control divide 6 divided by root 18 times root 130. Alrighty. Okay. So that's going to give me about 83 degrees if I'm rounding it. Okay. So about 83 degrees, somewhere there about. That's okay. Okay, that's what theta is. So that's the answer. Find the angle. Theta equals 83 degrees. Okay. Long, tedious problem, that one. Okay, so let's go on this one. This is the next part. All right, so I'm actually going to clear this page if I can. Okay, let's just get a big eraser. I have to erase all this because I need to work in the space here. All right, and then let's do this next question. So line L1 passes through A and is parallel to 1 and 4J. Imagine a vector, though, 1 and 4J, 1I and 4J, so 1 and 4. If I have a vector like that, it's going over 1 and up 4. That's what this is telling you right here. And there's a vector from this point to this point, and it looks like this. There's another vector, it says, that is parallel to this one. It's parallel to this one, that has a point A on it, and they're parallel. If that's the case and they're parallel, they're going in the same direction. This is 1 and this is still what? This is still 4. It's the same. So if they're going the same direction, they're giving you the direction by saying it's parallel to that one, because if it's parallel to that one, it has the same direction as that one. So remember, vector equations of lines are written as point plus some scalar times what? Times direction. They are telling me the direction is 1 and 4. That's what they're telling me right here. So they say 1 and 4. Okay, and they're actually calling this S, is what they're calling it. And then the point is just the point A, and the point A I already know from the question. Point A is right here. It's 4 and 2. So this is what they're telling me, and they tell me this right here. This right here is the same thing as this, okay, as this one right here. So that's how they're writing it. They're writing like that. So now they have another line that they're making up called L2, and it passes through point B, and it is parallel to that. So I need a point and a direction. So the point they're telling me is point B, and point B I already know is right here. It's actually what? It's 1 and -3. So it's 1 and -3. This is L1, by the way. This is L1. It's equal to this. And L2 is going to equal this one plus T, they say, times the direction. But the direction is given to me by saying it's parallel to that. If that's parallel to that, it's the same direction, so it's 2 and 7. Very well. So how do I write this mess? Well, that's the answer for this one. Let's write down a vector equation. So L2 is equal to 1, -3, plus T times 2 and 7. That's a really easy question for that one. But now they're telling me the lines L1 and L2 intersect at a point called P. And they want me to find the position vector for P. So figure out where they cross, in other words. L1 equals L2. That's how they cross. They have to be equal to each other. So I'm going to set this vector equation equal to this vector equation, and I'll solve it. So I have 4 and 2 equal plus S times 1 and 4. And this will equal this one, 1 and -3, plus T times 2 and 7. So what I basically have here is L1 right here, and this is equal to L2 right here. Okay? So let's actually figure this out by creating a couple of equations to make a system. 4 plus 1 times S, which is 4 plus S, is equal to 1 plus 2 times T, so plus 2T. Okay? They write another equation, which is 2 plus 4 times S, so 2 plus 4S equals -3 plus 7 times T, so plus 7T. Now I have to solve this system of equations for my two unknowns, which are S and T. S and T are not the answer, they are just scalars, okay? The answer is found by using S and T once you find them. So here's a system, and I'm trying to get rid of one of these variables. Let's get rid of S. What do I add to 4S for this equation to make 0? 4S plus -4S will make 0, but this is a 1. On the other one, I want it to be a -4. So what do I multiply 1 by to get -4? I multiply it by -4. In fact, I'll multiply the whole thing by -4. So -4 times 4 is going to give me negative what? -16. -4 times 1 is -4S. -4 times 1 is also -4. And -4 times 2t is -8t. Copy this one over. It's going to be 2 plus 4s is equal to -3 plus 7t. And now we'll add. So let's add these. -16 plus 2, -14. -4 plus -4s plus 4s, these just cancel. That's what I wanted. They're eliminated. -4 minus 3 is -7. And -8 plus 7t, -8t plus 7t is just -t. So now I'll solve this equation for my unknown value for t. So I'll just add 7 to both sides. It's gone. -4 plus 7 is -7, and that's equal to -t. So divide both sides by negative, so t is equal to 7. That's one value for t. Well, the value for t. So let's find s. So to find this, I will actually have to take the value that I just found for t, and I'll plug it into here. So t, I'm telling you now, is 7. So what's 2 times 7? 14. What is 14 plus 1? 15. That means that 4 plus s is equal to 15. Subtract 4. So s is equal to 15 minus 4. So s is equal to what? It's equal to 11. That's what I'm telling you right here. Okay. So I have s, I have t. So now I can plug 11 into s. And now I can plug 7 into t. So let's give that a try. this is 11. 1 times 11 is 11 plus 4. That's going to give me what? 15. 4 times 11 is 44. 44 plus 2 is 46. Here we'll plug in 7. 2 times 7, 14. Plus 1, 15. 7 times 7, 49. 49 minus 3, 46. What do you notice about this side and this side? They're the same. That's where the two lines will cross. That's the coordinate. So the position P is given by the coordinate 15 and what? And 46. That's where the two lines will intersect. That was that answer. Kind of tough, but not so bad. All right, moving on. Let's move this out of the way. Change my color to something else. Blue is fine. So let's find the vector OG. I want to find, we have a cube, okay, given by this, OA, B, C, D, E, F, G. And every length is 5. That's every length of each edge. So express each of the following vectors in terms of I, J, and K. If you notice here, I is this way. It's going in this direction. J is going in this direction, and K is going up and down, okay? So it's important you see that because we're going to be very, very deliberate about this when we're writing. So let me show you how this works. So I want to go from O to G, from here to here. That's what it says. So I want to go this way along the I direction. This distance is 5, okay? That's how long the side of the cube is. I'm going to go this way in this direction, which is also 5. That's 5 in the J direction. And then I'm going to go 5 up, which is 5 in the K direction. So 5 in the I, 5 along J, and 5 along K. So this is actually 5A, 5I, plus 5J, plus 5K. This ultimately will give me a vector from what? From here to here. And that's what I want, from O to G. Okay? So let's do that again, in case you're not sure what just happened, because this is really easy. And let's do another one. This one, I want B to D right here. So from here to here. So I want to go from here to here. I'm going backwards along I, but I'm going backwards, so I'm going backwards 5, so negative 5. And then I'm going up by 5 along K. So this is really equal to negative 5I plus 5K. What about the J? Well, I'm not going this direction this way or this way, so there is no J component. It's just not there. Okay? So, interesting to look at that way, but that's going to describe the vector from B to what? From B to D. It just goes this way and this way. Only 2 moves, okay? Let's talk about the last one. Let's actually erase that. Clear it up so you can see the next question. And let's get a pen that's green. So from E to B, so from here to here, I'm going to go 5 in the I direction from the origin here, 5 in the I direction, 5 in the J direction, and down 5 in the K direction. So it's going to equal 5I plus 5J minus 5K. That's what that is. So that's the answer for that one. That's pretty much it. So let's go on to the next question, which is here, number 6. I believe this is the final page. This is fantastic. So we're almost done. Okay. A triangle has vertices -1 and 3, 3 and 6, and -4 and 4. Very well. Show that the vector dot product of AB and AC is -9. All right. Well, there's 2 things I need to find that. I need to figure out what AB is, and I need to figure out what AC is. So I got to find those. So AB is B minus A. It's where it ends minus where it begins. And B, they're telling me, is 3 and 6. So 3, 6 minus A, which is -1, 3. So 3 minus -1 is 4, and 6 minus 3 is 3. AC is C minus A. C, they tell me, is -4 and 4. And I'll subtract A, which I already know is -1 and 3. So -4 minus -1 is -4 plus 1, which is -3. And 4 minus 3 is 1. So this is A, B, and AC, respectively. Now I need to find the vector dot product. Okay, so AB, the dot product of AB and AC, is given by taking the x times the x component. So it's 4 times -3. Then we add the y times the y, which is 3 times 1. So 4 times -3 is -12, and 3 times 1 is 3. -12 plus 3 is -9, and that's what they wanted me to show, that this -9 is in fact what that is. So check. All right. Show that to three significant figures, the cosine of BAC is this. All right. So I want you to consider this. When I say the cosine of BAC, they put this little hat above the A. That's telling you where the angle is. This is a point A, and there's some other point B. I don't know where it is, and I don't care. And another point called C. And I need to figure out a vector leaving A to B and a vector leaving A to C, because to use a dot product to find the angle, they have to be leaving the same point, which is A. That's why they put a little hat above it, right? So I need the vector AB, but I found it. I already have it right here. And I also need the vector AC, which I also have right here. So we already have the dot product and all this good stuff, right? So let's consider the dot product. The dot product of AB and AC is equal to the magnitude of AB times the magnitude of AC times the cosine of the angle between them. So the dot product we already found, we already figured out is what? It's -9. We already have this. This is -9. We already found it. We have to find the magnitude of AB. How? The magnitude of AB is these numbers underneath the square root squared. So 4 squared plus 3 squared. So that's 16 plus 9, which is root 25, which we now know is what? Is 5. That's what that is. The magnitude of AC is the square root of -3 and -3 squared and 1 squared. So that's the square root of 9 plus 1, which I now know is what? Is root 10. Okay, so this is root 10 times the cosine of the angle. Now, all they're asking me to show is the cosine of the angle. So I'm just going to solve this for the cosine of the angle. What I'm going to do is I'm going to divide both sides by 5 root 10. 5 root 10. 5's cancel, root 10's cancel. So this is gone. Cosine theta is equal to this. Okay. If I plug -9 over 5 times root 10 in a calculator, it will tell me that this is in fact equal to -0.569, which is actually what they want me to show. So that's what would happen. Okay. So basically, all this work right here would go in your answer here. Okay. Pretty nice. Final question, and then we're done. Thank goodness, right? So number 7. All right. A boat B moves with constant velocity along a straight line. Its velocity vector is given by 4, 3. At time equals 0, it is at point -2, 1. Okay. Remember that a position is a coordinate. It's x, y, and is given by the vector equation of a line. You'll have some coordinate where you're starting from, or some coordinate that you are at some point, any coordinate. And they're telling me at time 0, I'm at this point, which is -2 and 1. They're giving me a coordinate. I'm going to add time times the velocity vector, and they're telling me the velocity vector is 4, 3. So this. So they're telling me at time 0, if t equals 0, in other words, if this is 0, this whole thing is gone right here, which means all that is left is -2, 1. X and y is -2 and 1. That's what they're telling me right here. So that wants me to find the magnitude of v. That's the first thing. This is an easy question, not even relevant to this equation. It's just the magnitude of this. So it's the square root of 4 squared plus 3 squared. That's the square root of 16 and 9, which again is the square root of 25, which again is what? Is 5. That's really easy. Find the coordinates of b when t is 2. So they want me to take the value of 2, and they want me to plug it into here. So fine. What is 2 times 4? That's 8. What is 8 minus 2? That is 6. So 6. 3 times 2, 6, plus 1, 7. So that's the coordinates of the boat right here. It's this. Done. Done. Last question. Write down a vector equation representing the position of B, giving your answer in the form of this. Okay, I think I've already done that, all right? This is what I've done right here. I've actually already answered this question inadvertently. I didn't do it on purpose, but I did it already. I'm just going to copy it because it wants a vector equation. This is the vector equation of the position B where the boat is. So I already have answered this. This is already actually done. So this is your answer for that one. So I've done all of this. So this is it. That's pretty much how it goes. This is how a test would be, you know, in an SL situation if you're taking one with vectors. But that's all we got. So thanks for watching. Hope it's helpful, and good luck on your test tomorrow. All right, bye.